Okay, so this is a video on how to solve solutions to the formative that I gave on 5.3, transformations of a sinusoidal function. So let's look at the first question. So the first thing we need to do is factor out the k value. Factor out the k value so that we get the proper shifts, the left and right shift, or what we call the phase shift in the sinusoidal equation. So here this is going to be the same thing as minus 4 cos of 2 times x minus 15 plus 3. So from here, let's break down the various attributes from our equation. So here we got a is negative 4. So this implies that the amplitude is going to be 4. The next thing we want to look at is the k value. So k here is 2. And from there, we could decipher that the period is going to be 360 divided by k. In this case, it's 360 divided by 2, which is 180. So therefore, the period is 180 degrees. That's important that we specify the units. The next thing we'll look at is, let's look at the d value. So in case the d value here is x minus 15, again, my trick is what mix inside the bracket 0. In this case, that's 15. So that implies that's a phase shift because d is positive, 15 units, or in this case, degrees. And because d is positive, it's going to be to the right. And finally, the last one, we have the value of c. So that's going to be 3, and that implies that my equation of axes is y is equal to 3. So pretty straightforward. As long as we break down your equations into your a, k, d's, and c's, we can make the similar mapping to the various properties of a sinusoidal function. So let's look at the next question, which is a little bit more tricky. We're given a graph, we need to determine the equation. So given a question like this, in this case we need both one sine and one cosine function. So given an equation like this, I always like to get my peaks and troughs. It's easy to do, and it gives me half of what I really need. So in this case, the peak or the maximum value, we can see is over here. It's 9, the trough. Or my minimum value, in this case, we can see in this graph, we can assume the vertical scale is 1. So in this case, it's minus 1. So immediately we get two things. We get the amplitude. So the amplitude again is peak minus trough over 2. In this case, it's going to be 9 minus a negative 1 over 2, which is 10 over 2, which is 5. So once we have the amplitude, we know that we can have an a value of 5. Next thing we could get from our peak and trough is the equation of axes. So that equation is y is equal to peak plus trough over 2. I like to think of it as the average. So here is going to be 9 plus a minus 1 over 2, which is 8 over 2, which is 4. So here my equation of axes is y is equal to 4. And when we come off to determine the equation, this is very important that you draw the equation of axes once you get it. So here I'm going to just dot it in. And there's my equation of axes. Okay, and even once we get that, we could verify that the amplitude here is 5 from either going to my peak or to my trough. Both of those units are 5. The last thing we could get easily from a graph is the period. So I will just go from peak to peak. It's easy to see. So from here to here, I'm going from 40. And then the peak again happens at 60. So I'm going to define my period. So in this case, my period is 160 minus 40, which is 120. So that applies my k value here. K is going to be 360 divided by my period. So that was the equation. So we got 360 divided by 120, which is 3. So we got 3 of the 4 parts we have for our equation. Now, what are the actual equations? Well, the easiest one to start with is the cosine. Why? Because we know that the cosine starts at its maximum value. So remember, as a quick reminder, if it was to draw the cosine, it will look something like that, where it starts at the peak, comes down and down to the trough, back up to the peak. So in this case, since the peak happens here, and we can see that it's shifted to the right 40, that implies that's my d value. So here for the cosine equation, it's going to be y is equal to my k value, my a value here was 5, and then we see it's cos. In this case, my k value here is 3, and x minus my shift, x minus my d value, in this case, which is 40 degrees. And then we know the equation of axes in this case was 4. So it's going to be plus 4. Now the sine one, for the most part, it's almost the same. So basically we're copying it. Our a value is the same, our k value is the same because the period is the same. The shift is going to be different, so we'll leave that up for now. And the equation of axes is the same. So how do we determine the shift value for sine? Well, from a graph, it's easy to detect, and this is why I drew the equation of axes, because it's very important. The sine, so let me draw over here, this was cos. We know that the sine graph looks something like, it starts at the equation of axes, goes up, comes back down, and back to the equation of axes. So where do we see that on our graph? Coming along equation of axes, we can see that over here is at the equation of axes, and that's where sine starts going up. So in this case, we have a phase shift of 10 to the right, so that's going to be minus 10 degrees for my phase shift. So that's the two equations for the graph, one for sine and one for cosine.